I'm Sophie.
And I'm Bella.
Today we are here to discuss two separate analytical methods that can be used to determine the magnesium concentration in our lake water samples. Choosing an analytical method to determine the concentration of metal cations in water samples can be difficult, as earth metals will usually be in the milligram range and trace elements will be in the microgram range. I want to use capillary electrophoresis, or CE, to determine the magnesium content in our lake water samples. CE is the separation of molecules using electricity and a capillary. So how does CE separate the analyte that you want? Using the analytical method CE, ions can be separated not only by their charge, but also by its size. What is a capillary electrophoresis? So a capillary is a very small tube, and its tunnel walls are usually negative in charge, and they're usually made of bare fused silica. Electrophoresis means two sides, so two different buffer reservoirs, and one is positively charged and the other one is negatively charged. So a general CE setup looks like this. There are two buffer reservoirs. One has a cathode and the other has an anode. A buffer at a certain pH is used, depending on the analyte. A high voltage power supply is linked to the anode and cathode. The capillary has one end in the negatively charged buffer reservoir and the other end in the positively charged buffer reservoir. The sample is pressure injected or electrokinetic injected into the capillary. From there, the analyte will either pass into the negatively charged buffer reservoir or the positively charged reservoir. If the analyte is positively charged, it will move into the negative electrode. If the analyte is negatively charged, it will move into the positive electrode. Magnesium is a metal cation as it has 2 electrons in its outer shell, making it positively charged, and therefore it will pass through the capillary into negatively charged buffer reservoir. There is usually a detector on the capillary that sends data to an integrator or computer.
Well, I want to analyse our lake sample using the Atomic Absorption Spectrometry, or AAS method. We should use AAS to determine the magnesium content in our sample because it is a quick and precise method. AAS will atomise our sample using a probe that has been rapidly heated by passing a current through it. Our sample will then absorb different wavelengths of light depending on the concentration of the sample and then give a reading of the absorption, determining the magnesium concentration. AAS is commonly used in the medical industry to find evidence of important trace elements or poisonous substances like lead in the bloodstream. Due to its fast and precise nature, AAS is also used to maintain the composition of a substance and rule out possible contamination. Because of its ability to do so, AAS is used to measure the quality of water, hence why we should use it.
This technique relies on light being passed through a sample at a certain wavelength. Light starts at the hollow cathode lamp. Some of the light will be absorbed by an electron as it moves into a high energy state, so not all the light will pass through. The chopper separates the beam into 2 separate streams and uses one of these beams as a reference beam. Because AAS is generally analysing a liquid sample, like our water sample, it must first be vaporised in the furnace. The light then passes through the monochromators, which isolates a single atomic resonance line from the light emitted by the hollow cathode lamp. And the detector will sense the difference between what has been transmitted and what is being detected. The transmission will then be read on a computer.
seeing as I'm so convinced that we're going to use capillary electrophoresis to analyse these water samples, and you're so convinced to do AAS, maybe we should discuss the pros and the cons.
I think that's a really good idea.
My method has reduced consumption of reagents.
Well, my method is highly accurate with a rate of 0.5 to 5%.
Well, my method has fast analysis.
My method has high sensitivity and can measure to parts per billion per gram.
My method has high efficiency.
My method is low cost.
My method is relatively easy to prepare and also has a low cost.
My method is really easy to use.
AAS has a lack of versatility.
Well, in CE, the separation of the analyte suffers if the injection volume exceeds 1% of the column volume.
Well, AAS, the equipment is costly.
Well, in CE, it has sensitivity issues.
In AAS, if there's other metals in the sample, it will affect its precision.
So, who wins?
One eternity later.
I really did like your AAS.
Your CE was pretty good though.
I think it's a tie.
They're both pretty good methods, aren't they?
They're pretty good. Thanks for watching.
We'll see you next time on Analysis Methods with Sophie and Bella.